Hey guys, today I'm going to teach you how to compare box plots. By the end of this lesson, you'll be able to find the 5 key points in a data set and use those data points to draw conclusions about samples. So go out and get your binder, turn to the math section, and let's get ready to take some notes. All right, so the first thing I want to show you is what a box plot looks like. A box plot is just a visual representation of some data, and it's all about the median. So you'll notice in the box plot below, we have this red line denoting the median. This has nothing to do with the mean or the average. The measure of center we're looking at in a box plot is the median. Then you're looking at your lower quartiles, your upper quartiles, and that makes a box. You might also hear box plots called box and whisker plots. These are the same thing. People call it box and whisker because we have this box, and then we have the whiskers. The whiskers connect the box to the minimum and the maximum values. So what we're going to do today is start by figuring out what those words mean and how to construct a box plot, and then we'll compare. So the first 2 things that you should already know is that a box plot displays a data distribution using 5 key numbers. There are 5 key data points in a box plot. The difference between the first and third quartile is called the interquartile range, or you can call that the IQR. And you should have heard of that before. So we know to get the interquartile range, we have to subtract the first and third quartiles. The first quartile is the median of the lower half of the data. The third quartile is the median of the upper half of the data. In a box plot, the interquartile range is what makes the box. So you're going to look at Q1 here and Q3 here. Now you may have been wondering, well, where did Q2 go? We skipped from Q1 to Q3. Where's the second quartile? The second quartile is technically what we call the median. The median is the middle of all of the data, and that's that line right here. Remember, we find the median by lining up our data from least to greatest and then looking for the number that falls exactly in the middle. The 2 other data points that we're interested in a box plot is the smallest piece of data and the largest piece of data. That falls on either end of the box plot, so it makes the whiskers. The smallest piece of data we call the minimum, and we might abbreviate that min. And you'll see that at the lower extreme end of your box plot, we sometimes call that an outlier because it's the one that's different from the rest. It's the farthest to the small end. And then we also have the maximum, abbreviated max a lot of the time, and that's the upper extreme. That's the outlier for the upper half of the data. So now that we have these 5 definitions for the 5 key data points in our box plot, let's go ahead and start creating that 5-number summary with an example. Then we're going to sketch a box plot. I'm actually going to start by showing you how to do number 2 first. Then I'm going to have you try number 1 in just a minute. So watch me do number 2 and use that example to see how you can do number 1. In example 2, I'm looking at data for the number of hours a small candle will burn, and this data is randomly put down. Step 1 is going to be to order those numbers from least to greatest. When I do that, I pull out another sheet of paper, or I go off to the side. And what I want to do is I want to find the smallest value first. I see that it's 8, and I cross it out and write it in my new list. I do that so I don't write it twice, and so that I don't accidentally skip a number in order. If I was to keep going through these and cross out in order, I would start to realize, uh-oh, I got to the end of my list of crossing out, and I forgot to do a 7. 7 is actually the smallest number in this data set, so I've already made a mistake. If you do, that's okay. It happens. Just start by making a new list, starting with the new smallest number and cross out all over again. I would not try to squeeze the numbers in. Take the time, make a new list. So when you order the numbers from least to greatest, this is what your list should look like. Take a second, pause the video now to check that your list matches mine, and then press play when you're ready to check. Once I have organized my data from least to greatest, step 2 is going to be to find the median of the whole data set. And I do that by crossing off a number from each side until I find that I have one number in the middle. Remember, if there's 2 numbers, your job is going to be to find their average. Go ahead and tell me now, what is the median of this data set? Hopefully you realize that 11 is the median of the entire data set. So off to the side where it says that stands for median, I put 11. The next step is going to be to separate my data into 2 sets, and I'm going to use the median to center that. The first quartile is the first half of numbers. The third quartile is the second half of numbers. The median is like the halftime show. It doesn't get included in the game. It's going to be the thing that separates the 2. Because this is the median, there should be the same amount of numbers in this group as there is in this one. I can count that there's 6 in each one, so I know that I organized my numbers correctly. Now to find the first quartile, that's the median of the first half. So I'm going to do the same thing that I did to find the median of the whole group, and I'm going to do that to just this first section. I'm going to cross off 1 from either side until I get 1 in the middle. Since there's 2 numbers in the middle, I'm going to take their average. So 9 plus 9 is 18. divided by 2 is still 9. See if you can do the same thing with the upper half of numbers. Find Q3 from this set and press play when you're ready to check. You should have discovered that the median of the upper half of the data, Q3, was 15. Since they're both in the middle, they're both 15, we can just say that that's the median. Now that I've done all that stuff with median, I think the easiest part of this is going to be to find the minimum and the maximum values. You're just pointing to those two numbers. So what is the smallest number in the whole data set? And what is the largest number in the entire data set? Pause the video now, press play when you're ready to check. You can see that the smallest value is 7, that's the minimum, and the largest value is 19, that's the maximum. Now we're going to start creating our box plot. We're going to do it in the same order that we did these steps. My data points are already in order from least to greatest. Now I'm going to find the median. The median was 11. So I'm going to look for 11, and instead of plotting this 11 on the number line, I'm actually going to look a little bit above the number line and put a little line on the 11. And that's where you would start. Then you're going to look for Q1 and Q2. I have Q1 at 9, and I'm going to put a line on the 9. I have Q3 at 15, so I'm going to put a line on 15. Remember, Q1 and Q3 make my box. That interquartile range makes the box. So now I'm going to create that box for this on the box plot. I do that by connecting the Q1 and Q3 lines. Now for the minimum and maximum, that's what makes our whiskers. So it's just going to be a straight line out from the box to what it extends to. So it extends to a minimum of 7. I just drew my line out to the 7, and it extends to a maximum of 19. So another straight line to get us out to 19. And there you have it. That's how you create a box plot. So using our work from number 2 as an example, I'm now going to challenge you to look back at number 1, and we're going to try that one together. So I want you to start with step 1, order the numbers from least to greatest. Do that now and press play when you're ready to check. Once you have your numbers in order from least to greatest, your next step is to find the median. Go ahead and try that now and then press play when you're ready to check. You should have found 48 to be the median of the entire data set. Now your job is to find the median of the first half and the median of the second half. So go ahead and separate your data, find Q1 and Q3, and then press play when you're ready to check. You should have gotten Q1 as 45, Q3 as 49, the median of the upper and lower halves. And now your last step for the 5-number summary, find the minimum and the maximum. So point to the smallest number and point to the biggest number, and then press play when you're ready to check. You should see that 34 is the smallest number in the data set and 50 is the largest. Now I would challenge you to create that visual representation of this data, the box and whisker plot, and go in the same order that we just did to find each of the 5 data points. Start by plotting the median, Q1 and Q3, and then the minimum, the maximum. Do that now, create your box plot, and then press play when you're ready to check. It should look something like this. And then a point of note, it's called quartiles because there's actually 4 quadrants or quarters to this data set. This is the first, the second, the third, and the fourth. So that's just an example of a visual representation of how we can find median and use it to display our data. For question 3, we're not being asked to construct a box plot. We're just being asked to use the box plot to construct the 5-number summary. So we're just going to look at this and pull out the data points that we see. I know I'm going to use the lines that make the box. I know that that's the first quartile, the median, and the third quartile. And I know I'm going to look at the extremes. Those are the ends of the whisker, the minimum, the maximum. Then I'm just going to see what numbers those are pointing to. Pause the video now, see if you can figure that out, and then press play when you're ready to check. These are the numbers that you should have come up with: a minimum of 11, Q1 or the lower quartile of 12, the median of 14, the upper quartile or Q3 of 16, and the maximum of 18. You may not always be asked to just find the 5-number summary of a data set or a box plot. You may be asked to find specific information about a box plot. So these are 2 examples that you're not going to see on your paper, but I want to go ahead and get to these now. This one says the principal of Oceanside Middle School recorded the number of students in each class, and the question's asking about the upper quartile of the class sizes. The upper quartile is Q3. So go ahead and look at this box plot, see if you can identify where Q3 is, and then press play when you're ready to check. When I look at a box plot, these are the 5 key points. Q3 is what we call the upper quartile, and Q3 is at 26. So 26 would be your answer for this question. Here's another example of a question you might see. It says, for a health class project, Christina tracked the number of hours she slept each night, and here we can see that data displayed on a box plot. The question says, what was Christina's median number of hours she slept? So we're looking for the median of the entire data set. Go ahead and pause the video now, see if you can identify that, and then press play when you're ready to check. All right, so the median should be 8 because the median is always going to be the line that's contained within the box. Now, that's not always going to be in the middle of the box. It just happened to be in this case. You could see in our first two examples that we looked at, the median was the line inside of the box, and it was not in the middle of the box. However, that is the median of the data set. It's important to realize that is the median of the entire data set, even if it doesn't look like it is. It just happened to be like that in that last problem that we looked at. So now that we know how to construct box plots and interpret them, now let's start looking at comparing box plots. So in this example, we're looking at two box plots. We're going to look at some data within those to compare. In this case, Evan is going to look at the ages of voters who voted Republican in this box plot and Democrat in this box plot. He's examining specifically the variability of ages in those voters. So let's start by looking at just question 4. What is the difference in the measure of center of the voters who voted Republican and Democrat? When we talk about measure of center, we're talking about two things, either median or the mean. Those are measures of center in a data set. In this case, since it's a box plot, do you think we're talking about mean or median? You should realize we're talking about the median. Box plots are all about the median. So we're looking at the difference in the measure of center. That means that we're looking at the difference in the median in each of these box plots. So step 1 is going to be to identify what is the median of the Democratic voters' age and the median of the Republican voters' age. When I look at this, I see that the median Republican voter is about 49, and then the median Democrat voter is about 35, could say 36. And the question wants to know what's the difference in the measure of center or the medians of those voters. Take a second and remember, what does difference mean in math? Press play when you're ready to check. You should recall that difference means to subtract. When we're looking at the difference between two things, we're subtracting them to find out their difference. So go ahead and find the difference between these two and then press play when you're ready to check. You should realize there's approximately a 14-year difference in the measure of center between the Republican and Democrat voters. Question 5 wants to know what's the variability of voters who voted Republican and voters who voted Democrat. Variability is the IQR, or the interquartile range of our box plot. Remind me, what is the interquartile range in a box plot? You should recall that the difference between the first and third quartile is the interquartile range. So to find the IQR of Republican voters, I'm going to find Q1 and Q3. That's what makes the box. I see that it's at 40 and I see that it's at 60 for the Republican voters. The difference between those is going to tell me the variability. So the difference between 60 and 40 is 20. I subtract. See if you can determine the interquartile range of the Democrat voters. Pause the video now to do that and then press play when you're ready to check. When I look at the box plot, I see that 42 is the Q3 and 28 is the Q1. Remember, you could be close to that. It's not exact, just approximately. So either way, you should get approximately a difference of 14 years. So for question 6, it's asking about the difference in the centers relating to the variability. I noticed that the difference of the centers here is approximately equal to the variability in the Democratic voters. That's just something that I noticed. I also noticed that when I look at the box plot, there's a greater range of Republican voters, but less of a range in ages of Democrat voters. That doesn't mean that there's less data points. It just means there's a greater spread in the Republican voters. We can see that in a box plot. And then for the last question, you're going to challenge yourself to use your knowledge of box plots to answer the questions below. The box plots are displaying the median time in minutes on American Ninja Warrior courses. American Ninja Warrior is that show where they have to get on that course and do all these crazy obstacles to get from one end to the other. These are two pictures of examples. There's a Florida course and a Texas course. So the first question says, what was the median time for both courses? Go ahead and pause the video now and try to find that. Press play when you're ready to check. You can see that the median of the data set is the line within the box. For Florida, it's 10. For Texas, it's 11 or 12. I would go for 12 on this one. Question 8 asks which course appears to be more difficult. Since we can interpret difficulty differently, I'm going to change the question a little bit and say which course appears to take more time, and then explain your answer. So go ahead and think about that now, and then press play when you're ready to check. When I look at these two box plots, I can see that Florida is easier because it takes less time to finish. You can see that Texas has a wider spread overall, and also 50% of the people who participate in the American Ninja Warrior course finish after Florida's median time. Remember, each one of these quartiles is worth 25%. So I can see visually that half the people who do the Texas course, because 25 and 25 makes 50%, is over the median time for the Florida course. And then for the last question, it says a participant finished in 14 minutes in the Texas course. What can you conclude about that participant? In other words, which quartile did they finish in? The first, second, third, or fourth? You should be able to tell that the participant finished in the third quartile, which is above the median time. And that's how you compare box plots. All right, guys, that's it. If you made it to the end of this video, please put in the comments, where's your favorite place to go? Mine is to school. Today we learned all about comparing box plots. Now you should be able to find the 5 key points in a data set and use it to draw conclusions about a sample. So now you should go back to the calendar and complete any other assignments you have left for the day. Let me know if you have any questions. Bye!